Continuing on with chapter 20, starting on page 568. So we're still talking about biomass. Biomass power plants, now that's something that makes electricity, are more costly than coal and very uncommon for electricity generation. So we don't really burn trees to make electricity because it's really highly inefficient. Coal has like 4 to 10 times as much energy per volume. So it doesn't make a whole lot of economic sense to burn. When we have so much coal in the United States, we're not burning trees for electricity generation. We can burn trash for that in some states, not in our state, not in California because of our air pollution, but in other states they'll burn trash for electricity. It's called waste to energy. Okay, so going on to the next page, let's talk about biomass, page 569. So biomass that's used for automobiles are called biofuels. So the most famous example of a biofuel is ethanol. So a lot of our corn crop is not corn on the cob. It's actually field corn, which really has no flavor, and they turn it into ethanol, or they use it as food for animals. Some vehicles, you can buy a vehicle called a flex fuel vehicle because they can either run on ethanol or they can run on gasoline. The flex fuel, the ethanol is not pure ethanol. It's a mixture of 85% ethanol and 15 gasoline, so that's why they call it E85. We don't have very much of this around here. There's only a couple of gas stations that actually have that fuel, the E85 fuel. I think one's in Castaic. So if you have a flex fuel vehicle in Santa Clarita, you're probably going to mostly fill up with gasoline unless you can find an ethanol station. And why would you want to do ethanol? Well, sometimes it's cheaper. In the Midwest, where they actually grow corn, they have more ethanol gas stations, so flex fuel is more common in the middle of our country. Okay, but the problem with ethanol is that it's driven the price of corn up because now there's competition for this same corn crop. Well, how come you don't grow more corn? Well, we don't have the land space or the right climate to grow more corn. So the corn being used for ethanol instead of as food for animals or food for humans has driven the price of food up. It also doesn't really save that much because it still emits CO2. Now, less than gas, so it's better, cleaner burning than gas. But the problem also is that it takes fossil fuels to grow the corn, so you're not really getting much benefit from ethanol versus gasoline. So it's not the best solution to using fossil fuels in our cars. There's better solution, electric, hybrid, things like that. Brazil uses sugarcane instead of corn, so they make a lot of ethanol using sugarcane. In ethanol, there's a high energy investment, so the EROI that we talked about in chapter 19. So you need to kind of remind yourself about the economics of energy in chapter 19.1. There's a lot of energy investment to grow the corn, produce it, and process it, because it's a whole processing chemistry thing to get the ethanol out of the corn. So sometimes you got to make sure that you're going to make a profit, the energy return on investment, the ROI. Okay, so on the next page, you have here a gas pump that will have E85 or regular gas too. Okay, next page on 571, some other biofuels is biodiesel, which is made from used cooking oil. Some people get it from restaurants and they just put it in their car, and their car kind of smells like French fries because the French fries were cooked in that oil. So when they're done with that oil and it's too dirty and yucky to be used to cook with anymore in the deep fryers, then they'll sell it to people or give it away to people. So biodiesel is less emissions of greenhouse gases and air pollution. It's non-toxic, it's biodegradable, it's kind of cool. There's just not enough biodiesel in the world for everybody to use biodiesel. But some people have these cool biodiesel cars and trucks they've converted, like an old car to a biodiesel one, and that's kind of cool. And then another thing that they're researching right now is algae. So they're genetically modifying some algae to just take in tons and tons of carbon dioxide from the air, and then we can make a biodiesel out of it. So it can combat climate change as well. So that's a really cool thing that people are working on. Turn the page. So page 573, we have the cost effectiveness of different power sources. And so hydropower is super cost effective once you build the dam. Once the dam's already built, like some of our dams in the US were built 100 years ago. Like they're done being built, and now it's just cheap energy. So once the dam is built, it's really cost effective. And then coal is, oil and gas, and then you get down to these things. And ethanol is not very cost effective. It takes a lot of money to make the power for the price you get for it. On page 574, there's a lot of agricultural researchers who are trying to find better, efficient sources of ethanol than corn. And one of them that's really promising is switchgrass. So it'll give you a better return on investment with switchgrass than with corn. All right, so now we're going to talk about hydroelectric, which is under here, hydroelectric power. So hydroelectric power is mostly dams. So this is a dam in Washington. Inside the dam are turbines. So what they do is they let water in through the dam, and they put it through this little chute. And so the force of the water spins the turbine. And then the turbine releases electrons in a generator, which then makes electricity. So it's really clean, efficient. There's no greenhouse gas emissions. There's no air pollution. There's problems with dams and habitat loss and salmon and things, but it's really clean, efficient, renewable power and cheap once the dams are built. Okay, but there's some problems. Oh, but first let's talk about on 576 a different kind of hydropower that's not in a dam, and that is called run-of-river. And so sometimes homes that are kind of built next to a river, they'll have this intake pipe, and the pipe just kind of rushes through here. The water rushes through the pipe, which spins a turbine, which can power your house. So if you live next to a rapidly flowing river, you can build that kind of a system called run-of-river. Okay, so hydroelectric. The good thing is that it has no air pollution nor greenhouse gas emissions, so that's great. But the problem with hydroelectric is it can't expand in the U.S. Because we're out of good sites. Everywhere that's good to dam, we've already dammed. We dammed it decades ago. One of the problems with dams is in tropical countries is the reservoirs can breed mosquitoes because mosquitoes need sitting water to breed. So a running river, no mosquitoes. Sitting water, they can breed mosquitoes. So that's a problem because in a dam, you turn a river into a lake. So you turn running water into sitting water. And so more mosquitoes gives you more malaria and other diseases we learned about, like yellow fever from malaria or Zika. Okay, so it's cheap once built. Again, once it's built, it's cheap power per megawatt. So cheap per megawatt once it's built. So most of our dams, a lot of kids know about the Hoover Dam that's by Las Vegas. You can go and tour it. That's kind of like our closest kind of big dam. We actually have a couple of hydroelectric power plants off of the pipe, the Los Angeles Aqueduct. So up San Francisco Canyon, it's not a dam, but where the pipe comes down a hill, they use the force of that water to spin turbines in two separate locations up San Francisco Road. It's Powerhouse 1 and Powerhouse 2 for the DWP for Los Angeles, Department of Water and Power for LA, not for us, but for Los Angeles City. Even though the city land isn't here, that city still owns those power plants because they own that pipeline. It's the same pipeline that comes by Saugus High. Okay. So for dams, and most hydroelectric dams, there's habitat loss following the dam construction, and it costs a lot of money to build. Okay, so dams are super expensive to build, but once that cost is paid for, it becomes cheap megawatt power because you just need maintenance. And then it's like just run the water through, and it's really cheap. You just need people to maintain it, to upgrade equipment. But other than that, you don't have to dig coal out of the earth. It's really cheap power once it's made. But it costs a huge amount of money to build. The largest dam in the world is called the Three Gorges Dam in China. It displaced 1 million people. So it dammed the river, and it flooded all of these villages and towns that were next to the river for centuries. And those people had to move to other locations. So 1 million people were displaced, and huge amounts of habitat loss, and huge amounts of like religious sites that were flooded, and so it became very controversial. But it produces power for like millions of people in China in a clean, no heat, greenhouse gas emission way, no air pollution, and so in that way it's good. All right, that's it for chapter 20.